Hello. Once you open the Ansys window, you will get the window like this. After that, you need to go to your project section. From that, you need to click Insert HFSS. After inserting HFSS, you will get this type of window. After that, from here you can draw the 2D rectangular, circular, pentagon, hexagon, whatever may be. And this is the 3D boxes, 3D cylinder, all those things you can draw from here. So we are from before that I want to show what we are going to design. So this is the design we are going to do now. So this is the basic patch antenna operating at 1.4, not 1 point, I like operating at 6 gigahertz. Wait a minute, I will show the results. So this is the basic patch antenna. As you know, antenna consists of patch, ground, and the substrate. So I use the lumped port. We can use the coaxial feed also. Coaxial feed is nothing but from bottom to top we will use the connector. Here I use the connector from left side of the antenna. So first of all we need to find the dimension of the patch. For finding the patch width and length, you need to open Chrome and search patch calculator. You can see the website called Pasternak. Lot of websites are there. You can use any of them, but Pasternak is the best website compared to others. So you can see the dielectric constant. It asking for dielectric constant. The dielectric constant of the for epoxy substrate is 4.4. You can confirm the dielectric constant from the material while assigning the material also. Like you can see from here F4 you can see like relative permittivity. The relative permittivity is also known as the dielectric constant of the substrate. So the dielectric constant is 4.4, and then height is the basic height. The constant height is 1.6, 0.8, 3.2, like that. For epoxy 4.6 millimeter, not millimeter, 1.6 millimeter. The operating frequencies, as we are going to design the 6 gigahertz antenna, so calculate. As you can see, the width is 15.20 and the length is 11.32. Okay, so let's start the design. As you know, once you open, you will get this type of window. After clicking from here project insert HFSS, so let's start the design. You can use this 2D rectangular, but now I can't able to click here because the recording is here, like the stop, start, pause. The working of the recording video is here, so I can't able to click here, so that's why I'm using here draw rectangle. I click anywhere and drag it. That's it. From here, first of all, you can name it as patch. If you want, you can change any colors. Okay, then the X size. Let's see the size. The size is 15.20 and 11.32. X size is 15.20 and 11.32 or 11.32. So here in position we need to divide the value and put, so otherwise we can use minus 15.2 slash 2 comma minus 11.32 slash 2 comma, this is the patch, so it needs to be in top position, not in the bottom position, so that's why I'm giving the Z position as 1.6. as you can see now, the patch is in center. This is the, consider this thing as a graph, and this is the y plot and this is the x plot. So as you know, x means -1 -2 -3 -4, like that it goes on. In here +1 +2 +3 +4, like that it goes on. In that y also 1 2 3 4 5, like that it will goes on. So that's why the position. Hope you understand this point. So after that we need to draw the substrate. For drawing the substrate we need to get the 3D box. 3D box, click here, drag it, drag. You need to, before draw that, you need to click orient so that you can easily draw the 3D box. After that we need to find the dimensions for the substrate, like the 3D box. For that use calculator. The formula for finding the substrate size is 15.2, that means the patch width, plus 6 into 1.6, so you will get around 24.8. 15.2 is the width of the patch and 6 is the constant value and 1.6 is the height of the substrate. So we will get around 24.8. So we will round off the value as 25. 25 exposure needs to be what, either 12.5 or 25/2. You can see that the x size, we find the x size. Now we need to find the y size. What is the y size of the patch? 11.32. So simply you can same 11.32 plus 6 of 1.6 bracket plus gives 20.92. So we can take as 21. What size that size needs to be? 1.6. 21 minus 21/2 comma 0. You can see we drawn the patch. And the patch is in center position. Then afterwards we need to assign this box as FR for epoxy material, because it's basically assigned as vacuum. So we need to change the material from vacuum to FR for epoxy substrate. Okay. So it's assigned, right? So that after that we need to draw the ground plane. For draw the ground plane, go to again draw rectangular, drag anywhere like that. After that, as we know, the size of the substrate is 25 and the y size is 21. I mean the substrate size. Hope you will get this point. Then here -25/2 comma -21/2 comma 0. You can check, you can guess why I am putting the z position as 0. While putting the z position as 0, the ground is in bottom side. For patch I mentioned the z position as 1.6, so that's why it's in top side. So like that only. Then we need to change the name as ground. This is not a necessary one. You can, whether if you need means you can change the name, otherwise it's not necessary. Like the color also, it's not necessary. I'm just changing. Yeah. Then we need to draw the transmission line from here or here, this side. So for drawing the transmission line, again go to draw, click 2D rectangular, then draw from anywhere, but it will be easier If you click in the corner, drag like that, and this is the sides. Before entering into your PC, if you have a notebook, means kindly make a note of this measurement so you can easily type while entering on that HFSS software. The X size needs to be 2.9. Why 2.9? Because 2.9 mm thick transmission line perfectly match 50 ohm impedance line. There is a derivation for this one. You can find in online. So expression 2.9, 2.9 divided by 2 minus 2.9 divided by 2, comma, expression needs to be 0, comma, z position needs to be 1.6, because the transmission light needs to connect with patch, not with ground. The ground is in 0th position, the patch is in 1.6th position. Click OK. As you can see here, you will get the transmission line. Then you need to cut from here and here, because this is the in because we are designing the insert feed patch antenna, not a basic patch antenna. Insert feed patch antenna perfectly match the 50 ohm impedance. It works very well, so that's why I am using the insert feed method for the patch antenna. Click draw anywhere, and note that position, that's the thing. For transmission line, yeah, we need to change the name for your understanding. TR line, that means that is nothing but transmission line. Yeah, I didn't click OK, that's the thing. TR line, okay. No, I think it seems TR line. Yeah, TR line, transmission line. Then here we are going to cut. For making a cut in that, here we need to cut. What we need to do, we need to move this rectangular from here to here. For that, we need to adjust the x position. As you know, this is the minus x value, and here it's positive. Here we can see the x position is minus 7.6. What will happen if we put 0? It comes here, right? So it needs to be from here and here. So that's why before that we need to increase the size, the x size, as we will increase as 2.9 means 3.9, so that we will get a zero 0.5 cut on both side. Yeah, you can see that here it's starting, so it needs to go there. So that's why 3.9 minus 3.9 divided by 2. Okay, as you can see, here also there, here also there. And the optimized value, this will be done with optimization, like parametric analysis. So that's why I already did. So I will take the measurements from a previous project, the size of the cut. 3.9. On that left side you can see what was the x distance and y distance. The x distance is 3.9 and the y distance is 3.655. 3.9, 3 point, x size needs to be 3.9, and here it's 3.655. Okay, yeah, that's the thing. Okay, now you need to cut from patch. So before that you need to click the patch, then go to click control plus rectangular 2, then go to From here itself you can subtract it, but if you can't able to see this operation here, means go to modular. Here you can see the boolean. From that you can click subtract, patch to rectangle. You can see we cutted. Okay, now we need to merge the patch and the transmission line. For that you can merge from here, otherwise you need to go to modular, then boolean, then click unite. As you can see, we drawn the patch. Now we need to draw the port. We need to draw the port here. For that you need to change the coordinate system from x y to x z. You can, as you can see, x z z y. If we draw the port in this side, means we need to change the coordinate system as y z. But here if we need to draw, means we need to change the coordinate system as x z. After converting this, go to draw rectangular. You need to click here and drag like that only, no issue. Then go to here, and before that we need to give the name as port, and whatever may be the color as you wish. Not any, no need to do these things. Okay, then port, create rectangular. The z size needs to be 1.6. Okay, and the x is that is the width of the transmission line. What is the width of our transmission line is 2.9. Okay, so here 2.9 means 1.4 minus 2.9 divided by 2, comma, y position needs to be considered. Let us start from 0. Z position needs to be 0, because if I click the z position as 0, means it will start from here towards, go to this side up to 1.6, because we give the z size as 1.6. Okay, now come to y position. In y position we give a 0, so the port is in here, but the port needs to be here. So that's why we need to find what's the position here. In graph you can see this is the 0th position, 1st, 2nd, 3rd, 4th, 5th, 6th, up to n number. So that we need to find the position. Before that we need to change the coordinate system from xz to xy. Then go to measure position, from click here and click. See here you can see the x distance, y distance, z distance. We need to check the y distance. The y distance is 10.5. in the left side corner you can see on the dialog box 10.5. Okay, so the y position needs to be 10.5. Click OK. You can see our port come here. Okay, then fit selected. The port, you need to right click on that, assign excitation port, lumped port. Next, new line. Then you need to click here and it needs to drag towards top, and the x and y distance needs to be 0 and the z distance needs to be 0.8. that means minus 0.8, as you can see on the left side corner. Then click next, finish. Then the patch and ground, these two materials needs to be conductive material, that is nothing but copper. For that you need to right click on the patch, assign boundary, perfect electrical conductivity. For ground also assign boundary, perfect electric conductivity. That's it, we design the antenna. Then we need to assign the radiation box for our antenna. For assigning the radiation box you need to click on the patch, right click, create open region. Operating frequency needs to be 6 GHz. The radiation, it will be around 1 GHz for you, so convert from 1 to 6 GHz, whatever may be the operating frequency needs to be there, 6 GHz. Then click OK. It's in vacuum, we need to convert this material from vacuum to air, because our antenna works in air environment, not in the vacuum environment. Air, click OK. OK, then fit all. After that, wait a minute. After that, you need to give the input for the put. For giving the input, you need to go to simulation, setup, go to advanced. Frequency will be 6 and the number of passes. The more number of passes, the result will be more accurate you will get. So that's why I'm using 21 passes. Then click OK. Then from interpolation to fast, linear count to linear step, 3 to 9 GHz. The center frequency will be 6. It automatically assigned. Then the step size will be 0.01 gigahertz. Then click OK. Yeah, that's it. Now you can validate. Everything was validated. Design setting, cable setup, 3D model, boundary and excitation, mesh, analyze, optimization, reduction, everything is perfectly validated. After that, you need to click analyze all. After clicking analyze all, you can see the progress here. It's going on as adaptive pass 1 to up to 21 it will go. It will take only few minutes because this is the simple patch antenna. If you design the complicated design such as fractal design means it will take a huge time. As we know, this is the basic patch antenna, so that's why it will take only few minutes to analyze. Yeah, that's it. The simulation was completed. After that, for checking the results, you need to click here the results, then right click on it, then go to modern solution data report, rectangular plot, says parameter is 11 dB, then click new report. As you can see, our antenna is perfectly working at 6 GHz. For then go to here and double tap on that. In frequency, you need to click 6 GHz, then OK. As you can see, for 6 GHz we are getting the return loss as minus 28.15 dB as return loss. So our antenna was perfectly matched the 50 ohm impedance. So after that we need to check the VSWR. For checking that, go to create modern solution data report, rectangular plot, go to VSWR and the function needs to be none, then new report. Right click on the graph marker, add marker, click anywhere you want, then click escape button on your system, escape, then go click here. Here the frequency will be 6 gigahertz. Click OK. You can, as you can see, for 6 gigahertz we are getting the voltage standing wave ratio as 1.0814. So the 50 ohm impedance is matched. Again, if you don't like this kind of grids here means double tap here, the window will pop up. Go to grid section and remove this mark so that you don't get this type of grid lines. Close this window. Yeah, as you can see, on your mouse click the left button and you can drag these things, drag it, and you can place like this and it's ready to upload in that conference paper in journal papers. In S parameter also we can do these things. Go to grid, remove these things, then click OK. Yeah, that's it. So then we need to check how well our antenna focus the energy. For that we need to find the gain. Click on the right click, go to far field, 3D polar plot, gain total, then dB, last adaptivity to sweep, Go to families, the frequency needs to be in 6 GHz. Trace gain total dB, click new report. So this is the gain value of our antenna. We are getting the 5.15 as gain. Then right click on that, create far field, 3D polar plot. We need to find the directivity. Go to directivity, function needs to be in dB, last adaptivity to sweep, in family 6 GHz. Then click on new report. Then you can see this is the gain. We are getting gain as 6.63 dB. Then we need to check the radiation pattern of our antenna. For checking that, go to far field report, radiation pattern, gain total dB, last adaptivity to sweep, in families pi value needs to be, go to select value and click 0 degree and 90 degree, 0, and then scroll down, click control and then 90 degree. Yeah, from under that here you need to change the geometry from 3D to elevation. New report. So this is the radiation pattern of our antenna. As you can assign that we are using the full ground, so that's why the back lobe is so minimal. And if we are getting a good radiation pattern in that zeroth direction, that means the desired direction of our antenna. So we can see this one as the unidirectional antenna with coverage of wide degree, like the coverage is so wide. If we use the array antenna, means the radiation pattern will come like this. Yeah, this is the gain plot, radiation plot, and you can click here the gain plot too. From here click display and rectangular plot. As you can see, this is the 2D radiation pattern in the rectangular plot format. Add marker, click degree in 0, theta is equal to 0, click OK. In 0 we are getting gain as 5.1534 dB. Then we can check the current distribution. For checking the current distribution, you need to click on the patch, right click, plot field J, magnetic J, radiating surface, from last adaptivity to sweep, frequency will be in 6 GHz. Okay, then click done. As you can see, this is the radiation current distribution of our patch antenna. Then go to JSurf, click on that magnetic JSurf, on the right click, you can animate it. As you can see how well our antenna was distributing the current from the transmission line to the patch. Then close it if you don't need. Then we need to check, we can see the gain, like how well our antenna was radiating the energy, radiating the electromagnetic waves. For that, click on that patch, plot field, radiation field, gain plot, apply. Then you can close this window and you can see on that left click on the mouse and you can rotate the antenna and you can see, like in that back side the radiation is so minimal, and that in the top side, that means the major lobe was high and the back lobe was low. This is the basic patch antenna operating at 6 GHz. Hope you will get the point and you will get a overall idea about how to design the basic patch antenna using Ansys HFSS software. Thank you.